Hi, here's a quick example of function composition. I have here my function I of x equal to 6 over 1 minus x. And I want to do this composition here, I of x. So here's the thing. I set here 4 steps as a recommendation in order to get to the goal, which would be to find the composition and as well its domain. So first here for the first step would be find the domain of the input function. In this case, the input function is this one I of x, which is just the same function we have in here. So let's start by getting the domain of this I of x. This is a quotient here, and every time you have a quotient or division, you have to pay attention to what's in the denominator, which is the one below here. So this one here has to be different from 0. So it will be 1 minus x different from 0. In other words, it would be 1 or, well, x different from 1. So the domain of E would be all the real numbers except for 1 here. Now I'm going to proceed with this actual operation because we have done already the first step here, which is this one here. I'm going to check it. So let's continue with the I of x, I of x. So if I say I of x will be just the same as saying this. I'm going to input the function I to itself. So I'm going to replace every x with the actual definition of I of x, which is 6 over 1 minus x. I'm going just to write it like this. Okay. So I'm just going to proceed to do that. It will be 6 over this 1 minus, I'm going to use the color green just to make it clear what I'm doing here. 1 minus x. And well, basically from here on we have to just get along with the algebra here. I'm going to do it step by step so I make it clear. Will be pretty much longer here, so it will be, I'm going to multiply this this one here by the denominator here, 1 minus x, in order to be able to, you know, do the rational subtraction from here like this, and I get here this all below 6. So at the end I get with this expression here will be 1 minus x over 1 minus x minus 6 over 1 minus x. Now as they both share the same denominator, we can get them together. So it will get us to something like this. Like this. Oh, it's too ugly. Yes. Now let's just simplify this out. It will be here negative x minus, in this case will be minus 5. It's over 1 minus x. Now just keep in mind, I have this 6 on the denominator, which I can just write like this, 6 over 1. Now here I'm going to use the super famous sandwich rule to multiply these 2 and these 2. And then I will continue, I'm going to sign it with an arrow here. I'm going to continue in here. So I will get to this expression. It will be 6 times 1 minus x. I'm going to write it clearer. Minus x all over minus x minus 5. Now you can perhaps simplify this out a bit, or I mean not simplifying, just write it in a more proper way. I'm just going to leave it like this because I think it's just good enough for purpose of explaining here the point. Now from here, the only thing left is just to sign out. This would be actually the composite function here. Would be our I of, I'm going to use the same color just to make it clearer, like this. And this is actually our function, our goal function, our composite function here. And we are done with the second step here. And now we have to find the domain of the composite function here. So basically it's a case just like where we started. We have to look for what's in the denominator, which is in here because we have a quotient here. And this we have to do something like this. Negative x minus 5 has to be different from 0 in order to avoid an undefined situation. So in other words, x has to be different from negative 5. So the domain of this expression, I'm going to write it like this just to make it clear which is what I'm talking. I composed with I would be all the real numbers except for negative 5. But this restriction, this domain, it's only concerning this expression here. So this is not actually the final solution, because in the final solution we have to include the restriction from the function we were inputting here, which is this I of x, and it's the one we actually found in here. So we have to get together both restrictions, and the final solution would be all the real numbers except for negative 5 and 1. And this actually we got along with the third step just by getting this statement here, and just by adding at the end both restrictions, we just got along with the fourth step here, and that would mean that we are done. That will be all of it.